Oftentimes, the biggest hurdle to overcome for guided implant surgery is surgical access. The GRS Guide System, designed with that concern in mind, provides solutions to maximize surgical access. Adjustments can be made to a soft tissue model prior to using implant planning software, after a GRS model has been printed, and unique to the GRS Guide System is at the time of surgery if an entirely new surgical guide is needed. No other system in the world can provide for this combination of surgical access solutions. An initial modification involves the removal of 1 millimeter of model material to compensate for the platform thickness of the GRS locator pin. Depending upon the anatomy of the surgical site, the model material removed may involve a small area or the complete base area of the locator pin. To determine what area of model material should be removed requires using the locator pin with articulating paper. This is accomplished by simply inserting the shaft of the locator pin through the center of the articulating paper and then inserting the assembled unit into the hole in the model with the base of the locator pin and articulating paper resting on the model anatomy. Then proceed by placing vertical pressure on the locator pin combined with rotating the pin back and forth in a clockwise and counterclockwise motion to mark the area of contact. Once completed, remove both the locator pin and articulating paper from the model. Check the model to observe the marked areas of contact that can be removed to maximize surgical access. Although contact areas will vary from only small localized spots to much more defined areas, it is important to remove all the marked areas of contact in order to position the GRS ring in the lowest possible position. To remove the marked areas, simply take a lab burr and remove less than 1 millimeter of model material in the areas marked and repeat with the articulating paper to see if additional areas of contact appear. By taking the conservative approach and removing only small increments of model material at a time, broader areas of contact will be revealed with the articulating paper and can be removed to improve surgical access prior to fabricating the vacuform GRS surgical guide. Once 1 millimeter of model material has been removed, the final position of the GRS surgical ring will now maximize surgical access associated with the locator pin. If slightly more than 1 millimeter has been removed, the GRS surgical guide will slightly compress the attached gingiva at the surgical site and will not distort the planned orientation of the implant. This modification can be performed either prior to importing the soft tissue model into the implant planning software or after the GRS model has been printed. A more significant reduction can be achieved if a full thickness flap is planned at the surgical site. Using the GRS depth gauge, along with the tissue height measurements obtained clinically, set a drill stop at the measured length using the GRS depth gauge. For demonstration purposes, the depth gauge is set at 4.8 millimeters, representing the measured tissue height at the edentulous area. An initial pilot drill and GRS drill stop with corresponding diameters of 2 millimeters will be used to place the holes in the model to limit the depth of reduction. The GRS depth gauge measures in increments of 0.1 millimeter in order to establish precise osteotomy depth. It is important to place a series of holes in the edentulous area scheduled for the full thickness flap procedure in order to accurately position the GRS surgical ring prior to making the surgical guide. The pilot holes should follow the bone anatomy, and therefore all diagnostic resources such as X-rays and CT scans should be combined with the clinical tissue height measurements in order to achieve precise model reduction. The final collection of pilot holes should be generally distributed across the edentulous area in order to position the GRS surgical ring in the most anatomically accurate position relative to the bone. Once the pilot holes have been drilled into the model, simply use the holes as a depth limit when removing the model material in the edentulous site and to accurately shape the area to correspond to the underlying bony anatomy. It is important to consider the type of tissue access that will be utilized for each individual surgery in order to determine what steps will be needed in preparing a stone or 3D printed model to vacuum or pressure form a GRS surgical guide. By removing only to the depth of the pre-drilled holes, this will ensure for an unencumbered positioning of a GRS surgical ring and provide for an accurately fitting GRS surgical guide. An added benefit is that the surgical guide will isolate and protect the full thickness flap by creating a physical barrier between the drill and soft tissue. This process can also be performed either prior to importing the model into the implant planning software or after the GRS model has been printed. Now a GRS vacuforming assembly is simply inserted into the previously drilled hole if using a stone model, or inserted into the hole of a 3D printed GRS model. The adjusted model and GRS components should be viewed from multiple angles to ensure proper positioning. And finally, on the day of surgery, if certain unforeseen circumstances prevent the use of a GRS surgical guide as planned, additional reductions, like those mentioned previously, can be made to the edentulous site on the model, and a new vacuformed GRS surgical guide can be fabricated in a matter of minutes. By clinically evaluating the surgical site and noting what physical modifications can be made to the existing GRS model, a new GRS vacuforming assembly can be inserted into the newly modified model, vacuformed and trimmed in order to preserve the scheduled surgery. All the accuracy afforded through the use of implant planning software are maintained, and when combined with the GRS depth gauge and drill stops to limit osteotomy depth, the newly fabricated GRS surgical guide will provide the same precision and accuracy as the previous GRS surgical guide, but now with greatly improved surgical access.